Hey, you guys, just getting started. So hopefully we're going to get some people on here and get ready. Make sure that you guys ask me questions in the chat window off to the side. I will definitely be answering those questions as I get them. So if you guys want me to cover any topics, if you guys want me to answer any questions from homework, type them into the chat window and I will answer them. Again, if we don't have a lot of questions, this might end up wrapping up a little bit earlier than the hour. But again, I'm allotting us an hour to talk about any topics that you guys want. Specifically, I would like you guys to ask me specific questions from homework, tests, or the quiz that we had, or things like that. So again, type your questions into the chat window off to the side, and I will answer them in the order that I receive them. Let's see, going over some of our topics, just a reminder about them. So we have a lot that we've covered so far in this unit. So I'll just kind of cover some of our, a few of our topics down here. So we started off this unit talking about electron, energy, and light. You guys might hear my cat in the background, so excuse my kitty. She's in the background meowing at me. So we ended up talking about electron, energy, and light. We did a Poggle on that. Then we talked a lot about Coulombic's law, or the Coulombic Attraction. Oops, I can't spell. Let me go back. Coulombic Attraction. And we use this idea of Coulombic attraction to lead us into periodic trends. So our periodic trends are the trends on the periodic table that we can predict. So there were a couple that we went over. The main ones that we went over were atomic radii. Whoops, let me go back. We went over electronegativity. And we went over ionization energy. Once we went over all of those periodic trends, we started talking about bonding. So we talked about bonding in several different ways. We talked about the idea that we could talk about a bonding based off the electronegativity differences. And we talked about ionic, covalent, and metallic. We talked about properties of all these bonds. We talked also about how to name them. So you definitely want to know naming ionic and covalent bonds. And what we ended up kind of wrapping up with, one of the last things that we talked about were our Lewis structures. So our Lewis dot structures or diagrams. And these Lewis dot structure diagrams we created, and they are only for covalent bonds. So we can't draw Lewis dot structures for ionic bonds. These Lewis dot structures are for covalent bonds because Lewis dot structures show where electrons are being shared. So you want to make sure that you don't try to draw a Lewis dot structure for something that you can't draw a Lewis dot structure for. So make sure you guys are asking questions over here. Hopefully you guys can hear me okay. Type something into the chat window and let me know what you guys want me to cover. So I'll go ahead and take a minute again. Either go and look at your homework and ask me to solve a problem from the homework or anything like that. But again, go to the chat window, ask a question, give me a topic to cover. And again, hopefully you guys can all hear me well. I haven't had a problem yet with these, but make sure that you guys can hear me. If you guys want to drop me a message in the chat window, that would be appreciated. Could you do a couple examples of naming compounds? The two that would be great. Okay, awesome. Thanks, Claire. Let's go ahead and talk a little bit about naming. So if we talk about naming, so Claire had two examples that we can look at. So let's look at the two that she put on there. So BAI2 versus C3N2. So this is actually a really great example because this gives us a good difference between the two. So whenever you talk about naming, the first thing you want to ask yourself is it ionic or covalent? And the reason why is because we name ionic and covalent substances a little bit different. So when you are talking about ionic or covalent, the first thing that you want to look at is a metal. So if we look at this substance right here, we have barium and we have iodide. What if you look at your periodic table, which you guys will have one in front of you like you always do, you see barium. Barium is over on the far left-hand side of the periodic table. So this is a metal. And what that then tells me is that we're going to name this as an ionic compound because remember, ionic compounds have metals in them. Iodine is a nonmetal. So again, this is a metal, nonmetal bonded together. So it's an ionic compound. If we look over here, we see carbon and we see nitrogen. So we have carbon, which is a nonmetal, and then we have nitrogen, which is a nonmetal. So that means that this is a covalent compound. When we talk about ionic compounds and naming those, what you want to do for the rules for that is that you want to name the first substance exactly like it is on the periodic table. So you're not going to change anything. You're just going to name it exactly how it is. So if you look at what BA is, you see that BA is barium. And then you want to name the second compound, but you want to drop the ending and add IDE. So iodine becomes iodide. So let's go ahead and look at this one right here. So here we have a nonmetal, and a nonmetal is covalent. This is where you need to use your prefixes. And the prefixes tell us how many there are bonded. So for example, we have 3 carbons. So our prefix for 3 is tri. And we're going to name this carbon. So it's going to be tricarbon. And then we're going to name this di. And this is going to be N, that's nitrogen. But we're going to change the ending to IDE. So it's going to be tricarbon dinitrogen. Excuse me, nitride. Again, change that ending to IDE. Now, where naming becomes a little bit more complicated is when you are given, or if you're given the opposite, which you will be given on a test or a quiz. So let's say that you were given these 2 chemical formulas. Let's say that we have sodium sulfate, and we are given, I'm just trying to think of one off the top of my head. Let's say that we're given carbon tetrahydride. So we're given these 2 compounds, and what we want to do is we want to be able to write these, write out their chemical formulas. Again, just like we did up here, the first thing that you want to do is you want to ask yourself, is the compound ionic or covalent? You want to look for your metal. Sodium right here is a metal. Sulfate is a polyatomic, and polyatomics are only in ionic compounds, so we know that this is an ionic compound. Carbon tetrahydride, the minute that you see a prefix like this, that should be a big clue that this is a covalent compound. When you talk about ionic compounds, you want to make sure that you balance your charges. So you want to be able to identify what charge these will normally take on. So sodium, which is Na, is in that first column, and what we know is that sodium will normally have a +1 charge. Sulfate, on the other hand, is on your list of polyatomics. Your polyatomics will be on, I will give you those lists so you don't need to memorize those. But if you look at your list, you see that sulfate is SO4 and it has a -2 charge. We need to balance our charges. We can't combine these in a 1-to-1 ratio. So if this is a -2 and this is a +1, what that tells me is that I actually need 2 sodiums for every 1 sulfate so that when we add these together, they become a neutral compound. So this is going to be Na2SO4. So again, with ionic compounds, you must balance your charges. With covalent compounds, it's actually just a lot easier to name because you don't have to worry about trying to balance your charges. So here we just want to write down what we have. We have carbon. Notice that there's no prefix here. If there's no prefix on that first one, you just have 1. So this is just going to be C. You don't need to put the subscript 1. Then you want to know tetra. Tetra means 4. Hydride refers to hydrogen. So what that tells me is that I have 4 hydrogen. So this is going to be CH4. So make sure that you review a couple of the naming. There are a lot of naming problems on the back of that worksheet that I gave you that had the kind of that diagram on how to name the naming compounds. So make sure that you review some of those on the back of there if you're still unclear about the naming. Okay, can you summarize Coulombic attractions? Okay, so let's go ahead and talk a little bit about Coulombic attractions. So, Coulombic attractions. Coulombic attractions is the idea that oppositely charged particles we'll just say opposite charged particles are attracted to each other. Why is this important for us? This is important for us because we know that a proton, which is in our nucleus, is positively charged, and an electron is negatively charged. So what Coulombic attraction tells us is that there is an attraction between these 2 particles. Remember that our proton is in the nucleus and our electron is kind of surrounding the nucleus. So there's an attraction between those. And there are 2 things that Coulombic attraction and what we talked about with Coulombic attraction, what kind of happens with these. The first one is that if the distance between these 2 particles decreases, the attraction increases. So the closer these 2 particles get to each other, the more attracted they're going to be. The further away they are from each other, the less attraction there are, that force that holds them together. So if the distance decreases, the attraction increases. The second thing is the magnitude of the charge. The magnitude means how much positive there are. So is there a lot of protons? Is there not as many protons? So the magnitude, so the more, or we'll say the larger the charge, the greater the attraction. I'm kind of running off to the side here, you guys. Sorry about that. So if we have more protons, those electrons are going to be pulled in tighter. If we have fewer protons, they're not going to be held as tight. So that's our idea of Coulombic attraction, and we use this idea of Coulombic attraction to explain our periodic trends that we have talked about. So that is Coulombic attraction. Could we review polyatomic ions? Could you be more specific on what you want me to review about those? Do you just want me to do some problems with those? Some naming problems? Just let me know specifically what you want. Can you go over the last objective? Could you do me a favor and type out that objective? Because I actually don't have the objective sheet in front of me right now. I have all the homework, but not the objective sheet. So if you could actually type out the objective, I could address it a little bit more clearly, or briefly just say what that objective is so that I could address it in the video. Could we do a couple of polyatomic examples? Okay, let's look at some polyatomic examples with naming. So when we talk about polyatomics, polyatomics are only of, polyatomics are only involved in ionic bonding because, as we know, polyatomic ions are charged. Polyatomic. Okay, Lewis dot structures. I'll do some Lewis dot structures in just a minute. Polyatomic ions. So they're only in ionic bonds, and they function together as a unit. So there are that big list that I gave you, but let's go ahead and look at some examples that involve polyatomics. So I'll do a couple different examples. Let's do barium sulfate. Let's do magnesium hydroxide. Let's write the name for, let's see. Let's do this one. This is a good one. CuOH2. So let's work on these. So these all involve polyatomic ions. So let's write the chemical formulas for these, and then we'll name this compound right here. So when, again, you're writing the chemical formulas for these, you need to figure out what your charges are so that you could balance your charges. So barium, which is Ba, has a 2+ charge. Sulfate, if you look on your list, is SO4 with a 2- charge. That actually makes our lives a lot easier because these actually balance out. So all you need to do is write them together because they're going to be in a 1-to-1 ratio. So this is going to be BaSO4. Magnesium hydroxide. Magnesium has a 2+ charge. Again, if you look on your periodic table, it's in that second column. Hydroxide is a polyatomic, and it has a -1 charge. So notice that these don't balance out so easily. So what you need to be able to do is you need to say, okay, you know what? In order to balance this +2 charge out, we actually need 2 hydroxides. When you write out 2 hydroxides, you want to make sure if it's a polyatomic that you put parentheses around it. So if I'm going to show, again, that I have 2 hydroxides, I'm going to put Mg, parentheses around this because I want to show that this hydroxide is a unit that kind of functions together and sticks together. And you're going to put the 2 on the outside. So this 2 tells me that I have 2 of those hydroxides. Let's go down to this one right here. So here we have copper. And there's something very important about copper. Copper can have 2 different charges. It could either be a +1 or it could be a +2. We need to be able to, when we write out the name, reference what charge is going to be. And remember, we do that by having Roman numerals. Then we need to reference what this is. So we know that OH is hydroxide. And in order to figure out what copper it is, we need to figure out what charge hydroxide is. So again, we know that hydroxide is a -1 charge. If we have 2 of them, that means that this is all a -2 charge, which means, therefore, if this whole thing is -2, this copper right here must be a +2. So it's going to be the +2. So when I write this out, I'm going to write this as copper, Roman numeral 2 to show that it is a +2 charge. Remember that this does not tell you how many coppers there are. That tells you what charge copper is. And then you're going to go ahead and write hydroxide. All right, so let's go ahead and go over that last objective, which is drawing Lewis dot diagrams. So Lewis diagrams. So Lewis diagrams are really helpful because Lewis diagrams allow us to visualize how things are bonded together in a covalent compound. So we had a whole worksheet on them, so I'll go ahead and work through a couple problems, and hopefully that will help kind of refresh our memory about these. So let's draw a Lewis dot structure for, let's do N2. Let's do SCl2. And let's do C2H6. Okay, the first thing you want to do is that you want to draw the Lewis dot diagram for each of these substances. So you need to be able to understand how many valence electrons each of these atoms have. So in my first example, what this is showing is that I have two nitrogens bonded together. So I'm going to draw nitrogen, and if you look on your periodic table, you see what row it is, and you can find out that nitrogen has 5 valence electrons. So I'm going to draw two nitrogens. Each of them have 5 valence electrons. Remember that these want to form bonds in order to have an octet, which means 8. So these 2 electrons are going to get paired up, and that's going to form a bond. These 2 are going to get paired up, and these are going to form a bond. And then I'm just going to say these 2 are going to get paired up, which really we can move this one over here. But notice that I have to form 3 bonds. So I'm going to go ahead and rewrite this so that instead of having the circles right there, what we see is that we have 3 lines, which represent 2 valence electrons. So remember, each line has 2 electrons. And then we still have 2 atoms on each of them. So if we look at this and we look at each nitrogen, and we want to make sure that each nitrogen sees 8 electrons. So this nitrogen right here sees 2, 4, 6, 8. So it's good. And then this nitrogen right here sees 2, 4, 6, 8. So that's good. So that would be the Lewis diagram for nitrogen. Okay, let's go over here to SCl2. So that would be sulfur dichloride. So again, we are going to draw our 2 compounds. So sulfur has 6 valence electrons. And since sulfur is up front, sulfur is going to be in the middle. So we're going to have chlorine on the outside. And chlorine has 7 valence electrons. And then I'm going to draw another chlorine over here. And that chlorine has 7 valence electrons as well. So again, we're going to form a bond right here to complete our octet for each atom. So we have this electron right here is going to form a bond with this electron. This electron right here is going to form a bond. So notice that they're going to fulfill their octet. So we're going to redraw this like we did over here and redraw this showing that bond. And then we want to make sure that each atom sees an octet. So if we look at chlorine, chlorine sees 2, 4, 6, 8. So remember that bond represents 2. Sulfur sees 2, 4, 6, 8. So that's good. And this chlorine over here sees 2, 4, 6, 8. So that is good as well. Okay, now we have carbon. Now, when you come across a substance like this, and we have carbon and hydrogen, carbon is always going to make up what's called the backbone. So these carbons are going to be bonded together, and the hydrogens are going to be surrounding it. So carbon has 4 valence electrons, which means that it's going to form 4 bonds. And right next to it is going to be another carbon. And now we have 6 hydrogens. Hydrogen, remember, only wants 1 bond. So I'm going to go and only has 1 valence electron. So we're going to draw a hydrogen over here, a hydrogen over here, a hydrogen over here, a hydrogen here, here, and here. So if we look at this, we could see what bonds are being made. So this is going to form a bond. Here's a bond. Here's a bond. Circling those bonds that are being created. So let's go ahead and redraw this and make sure that they're all seeing an octet. So what your structures is going to end up looking like is something like this. So if we look at each atom, We see that carbon sees 2, 4, 6, 8 valence electrons, so that's good. This carbon sees 2, 4, 6, 8 electrons, that's good. Each hydrogen sees 2, and hydrogen only wants to form 2, or only needs 2, so we know that that's good as well. So those are your Lewis dot diagrams. You definitely want to be able to draw these and make sure that you're comfortable doing so. And again, there is that homework on there on drawing Lewis dot structures, so make sure that you go back and review that if you have questions on them. All right. Last objective, blah, blah, blah. Could you please review electron light and energy? Yeah, so let's go ahead and talk a little bit about emission spectra and electron excitation. So this is going to be energy and light. So we started off this discussion with energy and light by doing a demo. And the demo that I did is that I had some spray bottles that had different compounds in them. And when I sprayed them into a flame, they produced different colors. So one produced, I think, a violet. We saw a green, maybe, and an orange. I can't remember exactly which ones I did. But we saw 3 different colors. And what we did is that we wanted to figure out, why did we actually see a different color for each one of those compounds? And we end up looking at a POGL, a group discussion that we had that talked about this. So let's look at hydrogen. So let's say that we have a hydrogen molecule. Here's its nucleus, and it has these different orbitals. So we call these energy levels. So they say this is n equals 1. Surrounding that energy level, this is going to be n equals 2. And then we could have more, excuse me, as my diagram gets really messy. That does not look like a circle at all. But we have n equals 3. We could have more and more of these energy levels. And remember, these energy levels are where electrons reside. If this is hydrogen, hydrogen's going to have 1 electron. So what happens with this electron is that, for example, if we think about the demo that I did in class, is that this electron somehow absorbs energy. So here we have this electron. It absorbs some energy from the flame or something like that. It gets excited. And what I mean excited is that it's going to move to a higher energy state. So that electron gets moved up to this higher energy state because it had absorbed energy from some source, whether that's heat or light or something like that. And it gets excited and it moves up. It can't stay in this higher energy level for too long. So what ends up happening is that it's going to fall back down. Now it could fall back down to just a second energy level, or it could fall back down all the way to the first energy level. Depending on how far it relaxes or fallbacks down, you're going to see a different light or a different color. So let's say that this releases energy, and this energy again is going to be light. Now notice that this one didn't fall back down as far, which means that this is actually going to be lower energy. So this actually might be something like a red color, because red is lower energy if we think of our spectrum. So we're going to see some red. This one is going to release some energy as well, and it's going to be light. But that light, because it's going to be releasing more energy because it falls back down further, this is going to be a higher energy. This might be something like blue, which is higher energy on the colors. So remember, we have a couple different colors. If you think about Roy G. Biv, red, orange, yellow, green, blue, this is low energy. I'm just going to put E. This is high energy. So the further down this electron falls, the higher energy, or the more energy is going to release. So we're going to see a different color. So you just kind of want to know this basic idea about electrons being able to absorb energy and release light in different colors. And whatever color that it releases will tell you a little bit about how far that electron fell. And the colors that you see, so again, so we have something like that red and the blue. The colors that you see, those are what are called emission spectra. So that will be the emission spectra that you see. So you will see a red line, you will see a blue line, that is your emission spectra. Those are the lights that are being emitted. Do energy levels increase or decrease as you go down a period? As you go down a period, it's not that the energy levels increase or decrease, it's that you have more. So those electrons are going to be living in energy levels that are further out. So if you look at hydrogen, hydrogen's electron is only in that first energy level. It can get excited into a higher energy state, but it's primarily going to reside in that first energy level. As you move down the periodic table, you have more electrons, and so they're going to reside in higher energy levels. So they're going to be moving out. I hope that answers your question, Nico, about that. If not, let me know. Other questions that you guys want me to address on here? We still have some time, so I can address other questions. Or if you guys want me to cover any topics from or any problems from homework, I could definitely do that as well. So any other questions or topics that you guys want me to cover? Different types of bonding. All right, so we have two different types of bonding. Let me move over here. So let's go over bonding. We have two different, well, we have three. So let's talk about ionic. Ionic bonds are between two oppositely charged particles. I'm going to say actually atoms for now. And they have originally a large electronegativity difference. And the large difference is between a metal and a nonmetal. So a metal is going to have a low electronegativity, and it's going to lose electrons, which means that if it loses electrons, it's going to become a cation or positively charged. A nonmetal, on the other hand, has a high electronegativity, and it's going to gain electrons. And it's not just going to gain electrons, it's going to steal them from the metal, and it's going to be an anion, and that's going to be negatively charged. So an ionic compound, these are kind of the characteristics of it. It's going to be between a metal and a non-metal. The oppositely charged particles are then going to attract to each other, and they're going to form a bond. On the other hand, we have covalent compounds. Covalent compounds are due to sharing of electrons. So the sharing of electrons, and they share electrons because the electronegativity difference is smaller. Ion difference is smaller. So there's not going to be one atom that has a strong enough electronegativity difference to steal an electron, so they're just going to be able to share them. So this is actually between a nonmetal and another nonmetal. And they are going to share electrons, and they're going to have a small electronegativity difference. We did talk about two different types of covalent compounds. We have something called a polar compound, and this is where they are different atoms. And then we have something called a non-polar compound, and this is where they are the same. So for example, we might have HCl. Notice that those are going to be bonded together. They're going to be different. And they're going to be different because a chlorine actually has a higher electronegativity. So it's going to be slightly negative, while this one's going to be slightly positive. Nonpolar is going to be something like Cl2, where you have two chlorine bonded together and they're going to share those electrons evenly. The last thing, or the last type of bonding that you should know, is going to be metallic. So metallic is between two metals, or it's involved with any metals, so like copper, iron, they are going to have what's called a metallic bond. And what actually happens with a metallic bond is that you have electrons moving freely. And because they're moving around freely, metallic bonds also conduct electricity at in a solid state. These will not conduct electricity as a solid state. Metallic ones are the only ones that will draw, that will conduct electricity in the solid state. Okay, so I have some other specific questions. So let's go ahead and go over some other specific questions. I have one specific question of NH4. What's that say? NH4 to SO4. So right away, you see that this is kind of a complicated naming one just because there's a lot of different compounds. But what you want to think about is that you should recognize these right here. You should recognize these both as being polyatomic ions. And because they're polyatomic ions, that automatically tells you that this is an ionic compound. So what you want to do is that you just want to look on your sheet and you just want to figure out what these two polyatomic ions are. And you're just going to name them in that order. So if you look up at NH4, that is actually, and I'm going to get this one wrong, because I always call it ammonia, but I think it's ammonium. Let me make sure. Where's my sheet? NH4. Ammonium. I always get those confused because there's something called ammonia, and that's slightly different. So if you look on your polyatomic sheet, this is ammonium. So you're just going to write down ammonium, and then look on your sheet. This is actually sulfate. So this is just going to be SULFATE. So all we're going to do is go ahead and call this ammonium sulfate. So not too complicated, pretty straightforward. Okay, on the test, will there be anything referring to labs that we do? You should definitely know things about the labs, in particular about the labs. We talked about properties of metals and non-metals, and we also talked about properties of ionic and covalent bonds. So you should know what some of those things are that we learned from the labs. All right, we have a couple other Lewis dot structures. So we have H2O2. We have NH4 plus, NH4 plus, and we have, what's the other one? CH2Cl2, CH2Cl2. Okay, this one right here, this is actually hydrogen peroxide, just like you would get at the pharmacy or something like this. If you guys have ever had pierced ears, you might end up cleaning your pierced ears with hydrogen peroxide or something like that. That's what this is right here. This one's a kind of a more complicated one because it's not as straightforward on how to bond. But you can kind of start to think about this this way. So oxygen has 6 valence electrons. And there are 2 oxygens. If this oxygen right here has 6 valence electrons, that means that it's going to need to form 2 bonds. So the minute that you see that it has 6 valence electrons and you know that it needs 8, that means that it's going to form 2 bonds. So we have 2 oxygens that are going to form 2 bonds. You can't bond both of these hydrogens to one of these oxygens because then this oxygen isn't going to have any bonds either. So remember, hydrogen has 1 valence electron. over here. So what we're going to see is that actually a bond forms between right here, and a bond forms right here, and then these are going to share right here. So what we actually see is that we actually have a bond between the oxygens. And it really doesn't matter how you kind of orientate these. If you want both of the hydrogens on the same side, you could have one hydrogen going up here. You could have one hydrogen going off to the side. It really doesn't matter. But what you want to look at is that you want to now look at what each atom sees. So here's oxygen. It sees 2, 4, 6, 8. Here's this oxygen. It sees 2, 4, 6, 8. And this hydrogen right here sees 2 each. So then you know that is the correct structure. Serena, you only use parentheses when you have a charged particle. So let's look at ammonium. So ammonium has a plus charge, which means that it lost an electron. And I believe on your layout, what it says is that it lost an electron from nitrogen. So what that means is that nitrogen originally had 5 valence electrons, but with that plus charge, it only is going to have 4. So we lost a valence electron. Now we have hydrogens. We have 4 of them. Each hydrogen is going to need to form a bond. So I'm going to arrange those around here, because if nitrogen only has 4 valence electrons, that means that it's going to need to have 4 bonds. So the only way for nitrogen to have 4 bonds is to create a bond with each hydrogen. If I redraw this, I'm going to go ahead and redraw those lines, or redraw my bonds as lines. And because this is a charged particle, you need to put brackets around it to show that that's a unit and that the charge is on the outside. So when it is a charged particle, when it has either a plus or a minus, it's a cation or an anion, you want to put brackets around that structure, and you want to put the charge, whether that's a +1, a +2, a -2, or whichever one that is. All right, let's take a look at this one right here. So we have a couple different things going on. The first thing that you want to know about these is that usually the first substance that is listed, so in this case, this carbon right here, that's usually going to be your central atom. And if you think about this, carbon has 4 valence electrons, which means that it's going to need to make 4 different bonds. The only way for it to make 4 different bonds is to bond with each one of these. So there's no way for carbon to get its 4 bonds without bonding to each one of these. So I'm going to go ahead and I'm going to draw carbon with 4 valence electrons. Hydrogen has 1 valence electron, as we know, so I'm going to draw hydrogen right there. Chlorine, there are 2 of them, and chlorine has 7. So you can see that there's going to be a bond that forms right here. Right here, you can't really see it, right here and right here. So what ends up happening is that we get a structure that looks like this. We have carbon, we have chlorine. Don't forget to put those other dots on chlorine. That is important because those are its other valence electrons. Hydrogen and hydrogen. So again, double check to make sure that each atom sees a octet. So here's carbon, it sees 2, 4, 6, 8, so that's good. Chlorine right here sees 2, 4, 6, 8, 2, 4, 6, 8, so those 2 chlorines are correct. And hydrogen again only needs 2, and we see that each hydrogen sees 2 valence electrons. So you want to make sure that you guys get those. So there are some more problems for you guys. If you guys have any other questions, go ahead and drop them off to the side. I think I've answered everything that is on there so far. About 15 more minutes if we have anything else, or we could call it an evening. Again, you want to make sure that you just review your homework. You want to make sure that you review your quiz that I passed back, the one that I graded. And you definitely just want to kind of review your homework. And that's probably one of the most important things I could say to do, is to make sure that you review your homework. So any other questions? Are we good? Station number 2. Okay, so station number 2 is going to be a little bit hard to go over. Just because you need the diagram and there's not an easy way for me to bring up the diagram. But what I will do is I will go ahead and give you the answers for station number 2. So if you look at station number 2 was actually talking about ionization energy, and it gave you a graph that was labeled with just like X's and Y's, and then it gave you a chart with ionization energy. And it says, whoops, I just dropped my binder. Sorry, you guys. And it asks you what the W's are. So for example, the W's are hydrogens or alkali metals. So the W's are on the lowest portions. So if you see that kind of matches with your data table and what is there. So your W's are your hydrogens and your alkaline metals. Your X's, on the other hand, are the substances that have the highest electronegativities. And so if you look at your chart, you see that those are your noble gases. And then your Y's, which just have slightly more energy than your W's, or your alkaline metals, Y's are going to be your alkaline earth metals or your alkali earth metals. So again, W's are hydrogen and your alkali metals. X's are your noble gases, and Y's are your alkaline earth metals. So if you guys have more questions on that, if you want me to go over that in more detail, feel free to stop by at the beginning of the day tomorrow, and I can kind of show you the graph and explain a little bit more on how I solved that. But it's a little bit difficult for me to show that problem on the video. Serena, will we get a list of elements that don't need 8 electrons for the test? You will not get a list. There are 3 that don't require 8. Hydrogen only requires 2. Beryllium, Be, only requires 4. And boron, B, requires 6. So you do need to know those 3. I will not give you a list. What you will be given on the test is you will be given your periodic table. You will be given a list of your polyatomic ions, the exact same one that you guys have, that long sheet. And you will also be given a list of metals that have more than 1 charges and what their charges are. So you will have those 3 things on the test going forward. The other things you do need to know. So make sure you do know those 3 substances that don't need a full octet. Any other questions? I'll wait a minute, and if I don't say anything, we might say that we'll call it a night. We're almost done here anyways. I really appreciate everyone signing on and asking questions. I really hope that this was helpful for you guys and that you felt like this was worth your time. So will we be doing any extra problems from earlier units? You should definitely know how to do your dimensional analysis. So make sure that you go back and you review how to convert between grams, moles, and molecules. You'll always see those on a test just because those are so important. Kaya, I did talk about electron excitation and emission spectra. So when this video is over, go back to the beginning and you will be able to see where I discussed that topic. So go back to the beginning of the video. This video does end up saving to my YouTube channel when we're all done. Can you go over atomic radii and electronegativity? Okay, so this will be the last topic I go over. So I'll briefly talk about some of our periodic trends. Okay, so let's say that we have our periodic table. So here is my outline of a periodic table. And we have a couple different trends. So the first trend that we see is atomic radius. This was probably the biggest one that we spent the most time going over. So atomic radius, as you go across the periodic table, the atomic radius decreases. And the reason why it decreases is because as you go across a row, you have more protons in the nucleus, and when you have more protons into the nucleus, it's going to pull those electrons closer. So therefore, the atomic radius is going to get smaller. As you go down a group, I'm going to put AR, your atomic radius actually increases. And the reason why it increases as you go down a group is that you get more energy levels. So those you have more electrons, and those electrons are going to be residing in higher energy levels, and those are further away from the nucleus. Therefore, you have a larger atom. We have two other trends that we talked about. We talked about ionization energy. Ionization energy is the energy required to remove an electron from the highest energy state. So here I'll put IE for ionization energy. So as we go across, we said that the atomic radius decreases. It decreases, which means that those electrons are being held closer. If they're being held closer, that means that the attraction between those electrons and that nucleus is stronger, which means that it's going to be harder to remove that electron, which means that the ionization energy is going to increase. So again, ionization energy increases because electrons are closer to the nucleus, and the force between that Coulombic force is stronger. And so those electrons are going to be harder to remove. As we go down a group, however, ionization energy is going to decrease. And that's because as you go down a group, those electrons get farther away. As they get farther away, they're not held as, the Coulombic attraction decreases, and so they're easier to remove. So again, as we go down, it decreases. Our electronegativity is the idea that we can even say in a covalent bond, the attraction of a nucleus has on a neighboring atom's electron. So let me kind of just draw this out. And this was in your diagram. So here we have, let's say, an electron. Here we have a neighboring atom, and we have an electron. What this says is that there is an attraction between this nucleus and this electron right here. So how strong that attraction is called your electronegativity. So how strongly this nucleus is going to pull on that neighboring electron. So as we go across, because our radius decreases, this nucleus is going to be able to get closer to that electron, which means that the electronegativity is going to increase. As we go down a group, that nucleus is going to get further and further away from that electron, which means that our electronegativity is going to decrease. So one of the things that you want to remember with these is these trends going left to right, increasing and decreasing, that's your trend. That helps you predict which one's going to have a higher or lower atomic radius, ionization energy, or electronegativity. That does not explain why we see that. Again, the why and explaining why we see a trend is due to the Coulombic attractions. The ionization energy is, the idea with that is that those electrons are being held closer to the nucleus so that the ionization energy is going to be larger and things like that. So again, you want to be able to predict, if you were to compare two atoms, you want to be able to predict which one's going to have a higher or lower, say, ionization energy. But then you also want to explain why. And again, that has to do with your Coulombic attractions. So definitely make sure that you guys review those. If you go back, make sure that you review that homework sheet on it. So we had a homework sheet on that where you actually filled in the why. That's a really good homework sheet to go back and review to make sure that you understand and you can justify your reasons. So go back and review that homework sheet that was all about periodic trends. That would be a really good way to review. All right, you guys. I think that we are just about out of time. So again, I hope that this was helpful. I hope that, again, if you want to go back and you want to, the reviews in the classroom is what was homework, right? No, the review in the classroom was not homework. That was for your purpose only. The objectives is your homework. And then you want to stable everything together for your homework and make sure that you have it turned in to me tomorrow at the beginning of the period. Okay, so again, you want to go back and you want to make sure that you review your homeworks, do things like that. I hope that this YouTube Live was helpful. You can, this video will be saved to my channel, so you can go back and you can watch certain topics that I discussed earlier in there. We've talked about a lot of different things and done a lot of different sample problems. So go back, review those. If you guys have questions, you're more than welcome to stop by the classroom tomorrow. I usually am around there by 7. So review things, review the topics that I have posted online and things like that. Again, on Google Classroom, there are a bunch of videos that I put on there as well. So review. And if you guys have questions, stop by tomorrow. I hope you guys have a good rest of your evening, and I will see you tomorrow. Bye, you guys.